Alright, hello everyone. Starting today's stream for the project to port my flight simulator to the Godot engine. Last week, I did the very basics of starting this project, which means importing the model and porting the very core of the flight simulator code. And this week I want to expand on that and possibly add controller input so that you can actually move the plane around instead of just flying in a straight line. So what we have right now is a plane that can move forward and fly in a straight line, but there's no controller input or input of any kind. So this means the flight model is working, but we just need to modify it so that it actually allows you to control the plane. So we started by copying and pasting some of the code from the Unity project into Godot, and we're just going to continue doing that today. So I want to remove this debug statement. Then we need to figure out how to grab input from the Godot engine and then send that to our flight sim model. So I've already done the basic level of research for this, so I do know that we need to add several more methods to hook into Godot's engine. I don't know why they use the @ symbol for this. You don't need to call it event. I don't believe there's any actual source code for the base class. Yeah, it's empty, so we don't need this call to the base class. Okay, so this input function is what allows us to hook into the game engine, and then from there we can start reading the inputs that we need to set that are a part of the Godot engine. So that means we need to set up the input map to actually have controls that we can reference here. So I think the first thing we need to add is just basic roll, pitch, and yaw input. I don't actually know how to use this interface. Okay, from here we can just map these to the joypad axes, which is the controller. So we want to put yaw and roll onto the left stick. And we want to just continue doing this for all the other inputs. Okay, let's just do the yaw axis, or not the yaw, what am I thinking? No, I need the pitch axis. I gave the wrong names, but I did map it to the left stick, which is what I intended. Okay, so pitch control. Actually, Unity or Godot provides this API here to automatically combine the input axes that we need. So actually, we need to set up 4 of these at once. Okay, I don't think this actually needs to go inside the input method here. Since we're just calling the input class directly, I think this actually goes inside process. I'm not sure in what circumstances we would actually need to use the input method then. we need to rename all these strings to match what we're setting up in the input editor. And right away, this is something I don't like about Godot. This is just stringly typing everything, and it's just not a good way to design your API. But that's how Go is designed, because that's how Godot script is designed. So we just have to deal with this for now. Okay, that means I need to set up extra controls on the input map. And once again, I got the names here wrong. Okay, so I'm not exactly sure if that's the correct way to get input from this, the input map here, but this is what I'm going to try for now, just printing it to the console. Okay, so you see in the console at the bottom of the screen, this is actually moving as I move my stick around. I may not have set these axes up correctly because I don't think that behavior is correct. Okay, so if I go forward on the left stick, that should be a pitch down. But for some reason, the console is reporting no input on the left stick. And if I go left on the left stick, it's reporting this input correctly. So I must be I must be putting the wrong values into the input manager or something. Okay, we have pitch negative, pitch positive, roll negative, and roll positive. No, wait. Move left and move right. Move forward and move back. I may have just gotten the order of these incorrect. Although it doesn't really make sense as to why that would cause it to report 0 when going forward on the stick. Yeah, it's like reporting correctly on the left and right, not when going straight up or down. It says 0, 0 right now, but I'm holding the stick straight backwards, so that's not correct. So I must be doing something incorrectly with the input maps. See, this is a vector2 input. Okay, I really don't understand why this is not working correctly. We have pitch negative and pitch positive. The pitch positive is mapped to 1. Or sorry, it's mapped to up on the left stick up, which should correspond to move forward right here. So pitch positive is in the correct location. Yeah, I'm really not sure if I'm using this incorrectly or not. Hey man, I see some amazing stuff. Have you tried Bard, Google AI? It can help you code. I don't plan on using AI or any kind of AI assistant. I just don't think it's very useful when you actually start doing serious work in software engineering. It's updated with Godot 4.0 knowledge. Yeah, that doesn't really help though. Can you confirm you have the right joystick axis somehow? Yes, it's according to this input editor, it does say left stick down and left stick up. So it is possible that it's mapping the wrong input somehow, but it's not being changed by the right joystick either. How long have you missed the first part of the stream? I've been streaming since 2 p.m. on my end, so that's only 14 minutes from now. This is basically the first thing I'm working on here, so. There's an option to listen for input. Yeah, I know. There's also a function I was looking at. So instead of process, you call the input function. I wasn't actually sure how that matches with using input.getVector. Maybe you can print the axis of each. Maybe you can print the value of each axis individually. That's also possible. So what I'm trying to modify right now is the y vector of this variable. Oh, see, that's actually responding correctly to the changes. Sort of. No. Okay, when I go straight down, it reports 0. If I go sideways, it starts reporting non-zero values. There's something very strange about what it's reporting here. It doesn't go up to very large values. Okay, this behavior doesn't make any sense. Try the dead zone back at 0.5. Yeah, I'm trying that right now. It does not appear to actually change the behavior. Okay, when I move the stick, it actually reports values very close to 1. When I hold the stick at a position, it starts reporting values close to 0. It's almost like it's reporting the velocity of the stick and not the actual value, which is baffling. When creating a new mapping, you can pull the stick and needed access will be added automatically. At least this works for keyboard events. I'm not sure what you mean by that when you say pull the stick. It looks like all of these are just individual axes for left stick and right stick. Or sorry, for stick left, stick right, and stick up, stick down. Maybe it's relative and not absolute value. I don't know why they would do something like that. This is supposedly the correct way to get input from the input maps. When adding input, instead of searching for it, you can just perform the input. Oh, okay. That may actually work. Yeah, so this is recognizing stick up and stick down. And it is correctly mapping to joystick axis 1, left stick up, which is what I'm trying to map to begin with. But yeah, maybe it's relative, not an absolute value. I don't know what it would be relative to, because it should just be reporting the value of the stick itself. Yeah, so according to the gamepad tester, this is working correctly. Yeah, so I'm going full stick up here, and it's still reporting 0 for the up axis. When I start moving sideways, it almost reports the correct value. Not quite. Okay, well, I'm gonna use this other method they mentioned where you can just get each input axis individually. Okay, once again, it's not reporting the correct values on these axes. So it must be, maybe my controller configuration is wrong. I am just using a standard Xbox controller, so I don't know why that's not working properly. I think you need to flip positive and negative Y. I mean, that's possible. Okay, let's just try getting one of these by itself and seeing how that responds. Also, does get action strength work? I'm currently trying that right now. I have that on pitch negative. Yeah, this behavior is completely bizarre. It is like it's reporting the velocity and not the actual value. I don't even know how to describe this. Right joystick y-axis interpreted as x-axis. And that's not quite what the problem is. Changing all devices to device 0 fixes the issue. That might be the problem, because I do have multiple gamepads plugged in right now. I'm not actually sure which device this is registered as, though. Okay, I don't even think this is the correct device. I may be able to solve this just by unplugging all my other controllers. Okay, so that's being registered as device 0 now. Oh, there we go. I'm holding it down, it's reporting a value of 1. Okay, so Godot was just getting confused because I had multiple controllers plugged in. I don't know how it was like zeroing out all those values though. Because my other controller was not being used, so it should have just been at the neutral value. There we go, that's reporting the values correctly. Okay, so it might be that it was just receiving event reports from both controllers, and since one of them was saying that its position was at 0, just always reset the value to 0. So it just like combining the input from multiple controllers incorrectly. I don't know. But okay, we have that sorted out now. Let's see, I have pitch positive on the up axis. Okay, so once we actually have the input vector, we can just apply that to rotating the plane. So the way that would happened in the Unity version is that I just applied a torque to the rigid body, and there should be some way to do that as well in Godot. Okay, yeah, in the update steering function, I just apply a relative torque to the rigid body. And I do some other math to calculate what strength of torque to apply. So it was chaos all along. Yeah, I guess it's kind of unusual to have multiple controllers plugged in, but I guess Godot is like supposed to support like local multiplayer. I don't know. The input handling and the editor seems not ideal. Must take some custom code to get it right. I don't know. The code, I mean, it worked as soon as I went to a single device. So I think it was just that I was reading from all devices, which was not really a correct thing to do. Okay, so I can probably start by porting some of this into Godot. I don't want to set up the yaw controls right now, so we're just going to set that to 0. So this is just going to write to a new class variable called input or control input. We're just going to copy the values from stick input into here. So the x-axis is going to be the pitch. So x-axis of the control input. Wait, I forgot what convention I was using for this. Yeah, I think I translated here. So the y input of stick input, or the y-axis of stick input is going to be the pitch, which we want to map to the x-axis of rotation. And stick input dot x is going to be the roll axis. There was a drop down for selecting a device in the mapping menu. Maybe if you have it set device 0, but only that was the solution after all. All games I've played with correct controller handling will like somehow determine which input device is active and only listen to that one. Yeah, it was set to all devices by default, but that's probably not correct in the general case. Okay, so I need to translate some of these Unity API calls into whatever Godot offers. So vector3.scale does it just a component-wise multiplication of a vector 3, and there may or may not be something like that in Godot. There's some interesting functions here, but I don't think they have just a straight up component multiplication. whatever. It's not difficult to write this manually. Control input times scale. No, that would work if you were multiplying a vector 3 by a float, by a single value. But I'm trying to multiply a vector 3 by another vector 3. Okay, I also need to copy over some of these other functions as well. I actually don't want to write a G limiter right now, because that requires me to understand all the different conventions and axes they're doing. So this is just going to be return 1. Let's see. Okay, so speed, Godot uses -z as the forward, so that's what we need to extract here. Steering curve, we need to add another curve for steering. Turn speed is another vector 3 property that we need to expose. This is instead needs to be a function call. Okay, yeah, so control scale is going to be a vector 3. We need to multiply that with the control input, which is also a vector 3. Yeah, okay, so I can't apply rad to degree like a function. I need to also do a component-wise multiplication here. see, turn acceleration is another vector 3 that we need to add. And we need to get the calculate steering function. That ports over perfectly fine with no modification. Very fun coincidence there. Okay, and then finally we need to apply the torque to the rigid body. See, I was using relative torque in Unity, but there doesn't appear to be a relative torque function in Godot. So I need to actually calculate what the world space torque needs to be. I'm pretty sure you can just rotate a torque value by a quaternion. So whatever I was doing for quaternions earlier will also work here. See, I need to also convert this to radians. So one thing I find annoying is having to apply degrees to radians as a function instead of a constant. Because it means I just have to do all this component-wise stuff every time. A vec3 times vec3 should return a vec3 with each individual component multiplied by the right one. I don't actually know if that's correct. I didn't see a vector multiply operation earlier, but it's possible. Oh, that does work. Okay, when I was looking through the API earlier, I only saw the scalar multiplication. That does save some of this, some of the hassle. But as far as I can tell, I do need to apply degree to radians for each individual component. Unless there are overloads for this as well. No, it only takes floats and doubles. Okay, so final rotation. Times rigid body mass to ignore the rigid body mass. I need to call update steering inside the process function. Okay, so process is actually double for the delta time, which means I need to change the type of this. I'm not sure if I'm actually using this anywhere. Okay, I'm actually using floats internally. I'm just going to cast this to float. Are you using the built-in physics? Yes, I'm just using whatever Godot comes with built-in. I think I've heard that Godot has multiple physics libraries that you can choose which one to use, but I'm just using the default one. So whatever rigid body 3D is. Okay, that produced a ton of errors because I have not actually set up the steering curve or anything else on this plane. Let's just start setting these to some random values. Okay, so like we encountered last time, the curves in Godot only map from 0 to 1 on the input axis. So we need to actually remap our curve input from our speed in meters per second, which will be in the hundreds, to the range 0 to 1. So that means we need to add a new variable here to control where the speed is. Okay, there is an inverse lerp function. I'm not sure where this is located. Yeah, math F, that makes sense. Okay, so this inverse lerp function automatically converts from the range 0 to steering curve max speed, and it maps that to the range 0, 1, which is exactly what we need for sample. I couldn't use that in previous sampling functions because this range needs to be more complex than just 0 to 1. So and now that we have this value, we can set up the steering curve max speed, and we'll set this to 100. That just means that at 100 meters per second, which is like 200 knots, you get the full strength of the steering. And below that, you get reduced strength. Okay, so I was just moving the stick and it didn't move anything there. It must have an active collision shape 3D. I don't know if I actually put that here. No, I did. There's a collision shape here, which just represents a box. That should be enough to get the inertia tensor working. Inertia is a vector 3. Okay, multiplying by mass isn't really correct. You do need to account for the inertia tensor instead of the mass, but I'm not sure how exactly to do that, because I don't know if that's like in world space or local space, and just mass is a good approximation anyways. The other question is, why is this not actually moving? So it's possible the local velocity is being read incorrectly. Let's just use the debugger to look around. Okay, so speed is being read correctly. Steering power is fine. First, can you just try to apply a constant torque to see if it works? That's also possible. So I was thinking that speed might be read incorrectly, but that should be correct. So a constant torque is a good idea here. Yeah, so applying a constant torque works fine. That just means that somewhere along the way, something else is being set to 0. We are setting control input here. And we're reading that from here, which is, this is set to non-zero. I don't remember if local angular velocity is already in radians or if I need to... Yeah, angular velocity here is in radians per second. I need to convert it to degrees per second. Okay, hold on. Let's try using the debugger again. Okay, so the value being applied on final rotation is quite small. I'm not sure if that's the problem here. Okay, it may just be that I got my units mixed up. Because I'm trying to define the inspector variables to be in terms of degrees per second. So I want the turn speed on the x-axis to be 30 degrees per second. And the turn acceleration to be 30 degrees per second as well. Okay, let's just skip doing the degree to radian conversion. I did see it making a small rotation earlier. I don't know if it's just a problem with... Okay, that's actually working properly. I can roll now, but this doesn't look correct. Also, I don't have any pitch control. Okay, first of all, I'm going to increase the acceleration. I think I'm mapping the input axes incorrectly here. So move left, move right. Roll negative is left. I think I just need to negate these axes. And stick input.y should be pitch. That should also work properly. Why are you porting Flight Simulator? I thought porting Flight Simulator to Godot would be an interesting exercise. And as well as last week, there was that big controversy where Unity was like they were changing their pricing structure. So a lot of developers were interested in learning Godot Engine or porting their project to Godot. That's just why I started this project, to both the learning exercise and to help anyone else who wanted to learn Godot. But okay, what I'm seeing right now is that the pitch and the roll is actually working correctly. Pitch is very slow, and so is roll. But I'm actually able to fly the plane right now, sort of. I know earlier I turned off like the stability or whatever, I think, but this somewhat controllable right now. Also, I might just be at a very low airspeed. Wait, I can actually look at what my airspeed is. I'm pretty sure I can see that. Okay, so I can only see the airspeed and world velocity, but it is about 100-ish meters per second, which is very close to stall speed. So far, Godot has been given, I think, 300,000 since that little stunt with Unity by other game companies. Yeah, a bunch of people have said they're going to move to Godot or they're going to donate money to Godot. What is that Unity change? The only thing I've heard is that they charge 200,000 per download, which is a little bit unreasonable, so I have no idea what actually happened. They're not charging 200,000 per download, because that would be insane. Whenever you hit the $200,000 revenue for your game, they start charging per download or per install. So they're charging like 20 cents for every install, which for some games and some business models, that's enough to make the game completely unprofitable, which is why developers were so unhappy with it. So they have walked that back a little bit, but still some people are interested in learning Godot or moving to any engine besides Unity. Okay, so we actually have the control input working right now. It just feels really sluggish, and I'm not sure if I'm applying these units correctly. Especially, I don't know what unit torque is actually applying here. Okay, I'm just looking for what units these are actually using. This guy has the same exact question as me, and it's completely unanswered. I'm kind of expecting that this rigid body is using Newton meters for the torque unit, but I don't know. Godot is up to 50K on their dev fund. It was 33K a few days ago. Yeah, so that means 50K per month is what their dev fund is receiving from donations, which is yeah, that's enough money to hire a few developers. So Godot is definitely growing from this. Like they can put that towards adding features that other developers want to add. A torque you apply in Newton meters and a force in newtons. Okay, yeah, that makes sense. So I'm not. This should be correct. I don't remember why I even had this degrees to radians conversion. I think that is part of the math you need to convert degrees per second into a torque. I don't remember how I worked that out though. But anyways, I should make this ground larger so I can actually see where I'm going. Let's make this 2000 by 2000. And we can change this to 2000 as well. Mass would be in kilos, right? Sounds like they use SI units for everything to keep the math straightforward. I certainly hope so. I know Unreal uses a really weird system of math for all of their units. Okay, so we do have flight working right now. I'm going very low speed, and this turning feels very weak right now, but I'm not sure what exactly I'm doing wrong with the math. It could just be I'm at such a low speed that the controls are just naturally weak. I'm pretty sure I'm stalling right now, but I haven't actually written camera code. And I don't have any HUD to see what I'm doing either. Oh yeah, I'm going straight down. Have you heard of Nuclear Option? It's a very good game, similar to yours. Yes, I have heard. I have heard of Nuclear Option, and I've played it a bit, and I like it. Um, it is a pretty good game, and that is kind of what I'm going for with my own game development, which is definitely not as in the same state as Nuclear Option. Mine's still I'm still working on the very basics of it, and I'm moving very slowly because I'm working a full-time job as well. But yeah, if you haven't heard of Nuclear Option and you're interested in flight sim games, that's a good one to check out. Okay, so I think it might just be that all of my flight parameters are really weak right now. I don't remember what actual values I put in the Unity sim either. Uh, 30, 15, and 270. Okay, that's actually almost what I put here. And that should be enough to actually fly properly. Okay, the pitch movement is still very weak. I'm like still, yeah, I'm giving full pitch down and it's not moving, so I'm not sure. Again, I don't know what my airspeed is, so I'm probably stalling. Yes, this is basically stall speed. That's like 70 knots. And I cannot figure out where I'm pointing right now. Have you heard of YS Flight? It's realistic physics, but simple graphics. Could run it on old stuff. There's an appeal to that style. I have not heard of YS Flight, but I might check that out. Okay, for some reason the pitch axis feels really bad on this. Oh, you know what? It's because I'm not applying the inertia tensor correctly. So this rigid body is longer from nose to tail than any other axis. So it's just applying a very weak inertia on this. It's applying a very weak torque because the inertia on that axis is so strong. So I need to actually look up how the inertia works on these. The code is open source also. That's interesting. I will definitely check that out. Also, do you remember about how I told you about the issue with the yaw controls? That for some reason the plane wouldn't recover from it? Well, I fixed it somehow. I still don't know how. I think I remember you mentioning that, but I haven't looked into the code since then. But if you figured it out, then that's great. Okay, I need the actual documents for the rigid body. Okay, so instead of multiplying by rigid body mass, I think we just need to multiply by the inertia tensor. I don't know if the inertia tensor is in world space or local space. I'm pretty sure it's supposed to be in world space. Anyways, my own air combat game is now progressing quite well, and I've implemented particle systems. Half of my time is now spent crashing the plane in play mode. It's great to hear. Uh, yeah, I've heard a lot of game developers were helped out by my by my flight sim code, so that's nice to hear that other people are using it. I just updated the way the rotation works, and now I'm not moving at all. Okay, so I guess the default value that it returns when you read from inertia is also 0, which is not helpful because I need to know what the actual inertia tensor is at runtime. Okay, so there are functions for getting the inertia tensor. I don't know how to apply that though. Or rather, I don't know if inertia or the inverse inertia tensor is relevant here. I don't really want the inverse inertia tensor, but reading this value just returns 0. I'm pretty sure. Yeah, the inertia tensor is just 0 if you don't give it a value, which means it exists internally, but they aren't. This value does not change when inertia is automatically computed. Use physics server 3D to get the computed inertia. I have no idea what physics server 3D is. So I need to look up the API for this. Okay, this is for physics server 3D, but the description is about 2D. Very helpful. Okay, there's a body parameter enum. A body set param. Oh my god. Okay, so this returns a variant. And then I just need to use this enum to get the inertia. Okay, so I was reading posts about the design of the Godot engine, and the fact that so many of their APIs return a variant instead of just some direct type is not good for performance. So I need to cast this to the correct value. Well, I don't know what value it returns. Go here, it says body parameter inertia to get the body's inertia. It doesn't tell you anything about what value to pull from the variant. I'm going to assume that it's going to be a vector 3. So if we multiply by the inertia tensor, that should result in the correct value. Okay, it appears this is still 0, so we're not getting the inertia correctly anyways. No, that's a value. But it's still not responding to input now. Oh, this is not a number. Because this is not a number. Because the local angular velocity is also not a number. Okay, somehow the system is being poisoned by not a number. Which is possibly because I'm not applying the inertia tensor correctly here. Shouldn't the inertia tensor be a matrix? Actually, you're right. It probably does need to be a matrix. Which means that vector 3 is not going to work, but I don't know how to convert this into just a value that I can multiply. Okay, so I'm just going to use the debugger to see what the actual type is. Now the type it's returning is vector 3. And this looks like what the inertia tensor should be. Or maybe that's a bit too large, I don't know. Okay, yeah, so the actual problem is that the angular velocity is still set to not a number. So I have a feeling that applying the torque in this way results in a not a number. Uh, does hot reloading work here? Appears not. So I don't know what exactly the issue with this is. Yeah, we're getting not a number for the angular velocity. Somehow calling this value results in not a number. I see another API, get body direct state, that returns the whole state. Not sure if that's the right thing. There's no non-inverse. Yeah, I don't think I need the inverse. I think I need the inertia tensor directly. Because I'm trying to make it so that I can just specify rotation in degrees per second, not have to worry about the inertia at all. But then again, I don't know if that's the correct math to use here. Okay, so one annoying thing about Godot is that I cannot just launch the debugger and have it freeze on the first frame. Yeah, I have to do this hacky process where I use Godot script to freeze it, and then I can launch the debugger in C#. Wait, how do I make this continue? Ah, see, that's the problem. Like on the first frame, this variant is returning infinite on everything. So then multiplying all this into the apply torque method results in nothing, or results in not a number. So I guess that's what I need to check instead of nil. I need to make sure this variable is not infinite. Check your debug errors in Godot. Set axis angle, vector 3 must be normalized. That's probably related to what I was doing earlier. But there's nothing here explicitly about using infinite or not a number. So, okay, I hope by filtering out infinite values that we'll get the correct behavior. So if it is infinite, then we skip this section. And hopefully after the first frame, it's not infinite anymore. There we go. Okay, we're actually rotating the plane now. I'm gonna skip final rotation again because I think that's incorrect. There we go. That actually, we're flying correctly now. There we go. I think I'm still calculating the torque value incorrectly, but this is a lot better. Oh, it's actually very stuttery, which kind of implies that some value is incorrect here. Or it might just be that I was in stall speed again. But yeah, now I can actually pitch correctly. Okay, I'm getting some kind of... I'm not giving a roll input right now, but it's still rolling. So actually, there's something incorrect happening here. And it's also stuttering as well. Now, this might just be because I just translated a bunch of code from Unity to Godot, and so it's not calculating all these values properly. Yeah, so it's just giving me a small but rotation around the roll axis right now, which I'm not commanding. If I correct it, it kind of becomes stuttery and random again. But we are flying now, so that's a step towards the successful flight sim. Okay, I'm looking at the velocity here. Okay, you know what? It might be because I'm applying the inertia tensor in world space. The documentation doesn't say which space, whether it's in local space or world space, so I don't know if that's correct. Let's see, if we move the parentheses, so now we're doing correction times inertia tensor, and then translating that to world space. That may solve the issue. Yeah, there we go. That's a lot smoother. So I think I was applying it in the incorrect space. Okay, the other issue that I'm seeing is that I'm not really able to go faster than 100 meters per second. Even though I'm flying pretty straight and level right now. The z-axis speed is not really increasing beyond 100 meters per second, which is about 200 knots. That's still just barely above stall speed. That may be because I'm applying drag incorrectly. Although I think I'm not applying drag at all. Yeah, induced drag is also 0. And I don't think I apply drag. I'm not sure why this is so, like, the engine is so weak. That looks more responsive. Yeah, that I was applying in the wrong space, so it was like applying world space rotations that were incorrect when I was trying to do local space rotation. So I think the turning code is actually correct now. If you're familiar with my project, there's still quite a lot you need to translate in order to get a fully like feature parity with the Unity 3D version. So off the top of my head, we also need to add drag and induce drag to tune those values. The G limiter, camera movement, and then the weapons and AI. But yeah, we're making good progress on this right now. Let's see. I need to figure out why this is not going faster than 100 meters per second. There's something like a max velocity on the physics objects. And I don't think there is like a global max velocity. Vector 3 usually with delta is huge in Godot. I'm not sure what you mean by that. Okay, one thing I can do right now is set up the yaw controls, the rudders, because I don't actually have those working. Okay, so that should add yaw input to our controls. The other thing I need to actually apply yaw physics. See, I already translated these functions, so that should apply just fine as it is. If we do that, we should be able to yaw the plane. Okay, the yaw controls are backwards, but those are working fine. Okay, I'm not sure what just happened there. I completely fell out of the sky. I think the yaw just killed all of my forward speed. Oh no, I'm not applying induced drag, so I'm not sure what just caused that. Okay, by moving sideways, I'm now losing a lot of speed and not regaining it. Okay, there we go. That's like back to a normal-ish speed. Okay, no, I'm moving sideways right now. That's not correct. I think I might have just not setting up yaw correctly here. No, I'm sampling the AOA curve correctly. Okay, again, it would be very easy to debug this if I had some kind of debug that draw lines, which is exist in Unity, but it doesn't exist in Godot. Like, I don't want to set up the HUD right now. If I could just see what my velocity vector was, that would make this a lot easier. Okay, but the problem I'm seeing is that I'm not getting the correct value when the rudder is being used, or when turning at all. I've never seen anybody use C# with Godot before. Yeah, if you're going to use Godot, I recommend using C# because it's better than Godot script. Delta controls movement based off of frame rate and frame rate independence, so to move an object at a constant speed or increase with velocity. Oh, okay. Yeah, so just means frame rate independence. Yeah, that's kind of standard for game engines. But I think you're on a huge delay because I asked that question like 5 minutes ago. Okay, this behavior is very weird whenever I yaw. Kind of hard to tell what my actual velocity is right now. Oh, debug errors. Okay, so there's some kind of error in their native interop. See, I have rudder negative and rudder positive. So I'm calling these names correctly. But something here is causing there's some kind of error in the C++ layer. Yeah, get action strength is returning some kind of error, or it's causing an error. Rudder negative and rudder positive. Oh, is it a typo? See, this is why I don't like stringly typed languages. And Godot's API is stringly typed. Okay, well that solves the bugs I was facing, but the other issue is that I still get weird behavior when I yaw. At least I think I do. Oh yeah, I just hit the ground right there. I lost so much speed that I stalled out. I seem to be drifting sideways. There was a plugin in the asset library for debug drawing, but it's Godot script only. Yeah, it would be nice if there was a way to do that from C#. There's probably a way to call Godot script from C#, but I haven't figured that out yet. Like I said before, C# seems like a second-class feature in Godot. Yeah, I'm moving towards the edge here. Again, I can't really tell what my speed is or what my velocity vector is, but I can kind of see how I'm moving relative to the ground. Yeah, I'm falling straight sideways right now. And now I'm just moving sideways. Is there any method to check whether the plane is stalling or not in the flight controller you made? There's no explicit function to get the stall, but I mean, you can, like, the way a stall happens in actual planes is just whenever your AOA is too high. So the angle of attack, whenever it's higher than the value, or higher than the peak of your AOA curve, you're in stall. So when you're flying straight and level, you're here next to the 0. When you start pitching, you move to a new AOA, to a new part of the AOA curve. And when you stall, or when you pass the peak, and you enter this region, that's the stall region. So strictly speaking, just measure the AOA and that'll tell you whether or not you're stalling. But there are some other ways that you can kind of approximate it as well based on speed. So like you can calculate what your stall speed would be that would result in your AOA stall. But there's nothing that actually calculates that in the flight sim that I've released. Okay, so I might be applying the rudder physics forces incorrectly. Rudder power, rudder AOA curve, rudder induced drag. Maybe I'm calculating angle of attack yaw incorrectly. What if the y variable in local velocity becomes greater than the z variable of it? Could that also be called stalling? Kind of. That would imply that you have an AOA of greater than 45 degrees, which is in the stall region for most planes. So that is one way to measure it, but that's kind of like an indirect way to measure stalls. The other thing you can do is like calculate how much lift force you're generating and then compare that to the weight of the plane. And then like if it's above some threshold, like if you're less than 50% of the lift you need, then you can call that a stall, but that's kind of a little bit finicky to do as well. I've like done stall warnings before, but I don't remember off the top of my head how I did it. Okay, so if I change the angle of attack yaw, and I use positive Z instead, I wonder how that makes it behave. That actually looks more correct. Okay, this featureless plane makes it very difficult to tell how fast I'm moving or where. But I think this behavior is more correct than it was before. So again, Godot uses different coordinate system. All the math I did for Unity was based off of Unity's coordinate system, and I've just been trying to kind of hastily translating it to Godot. So I'm not exactly sure what the correct one, but apparently I've just been like flipping around signs, and that moves towards the correct values. Could you base it off a vector when reached at a speed it will stall? I'm not sure what you mean by that. Yeah, this flight looks a lot better now. So before I was moving sideways when I got to an extreme yaw, but now I'm actually moving correctly. Okay, so that's like the basic flight code done. Well, actually, no, I need to add like drag and induce drag as well. I wonder what else I can add right now. I don't really want to do animation because it's going to require like figuring out a better structure for all the code. Could you detect stall by checking if the nose is angled above the horizon and the plane is moving downwards in space? Like the stall is calculated by the angle and speed. Hmm. Basically, if the nose is pointing upwards and the velocity is downwards, that would be like, again, that just means that your AOA is large enough that you're causing a stall. Because ultimately, that's the only thing that matters is how large your angle of attack is. But like you can approximate it again using the weight calculation that I made earlier. Again, I don't want to, or I can't figure out exactly how I implemented that before. Just for a stall warning alarm, I mean, yeah, that would work for just a warning. Okay, well, I think the next things I would need to add for this are the HUD and the animation system. I don't really want to do that today, though. I think that's a better topic for like the next stream I do. So if I do another stream on this, it's going to be next week, probably same time on Saturday again. Is it possible to pull really hard in this implementation, something like a Pukachev's Cobra? Um, it is if you reduce the like, or if you increase the strength of the turning the steering curve, I guess. I've actually done something like that before in the Unity version, which I would find a lot easier to actually demonstrate this on. But basically, just increase the amount of turning you can do, and you can actually do like a Pukachev's Cobra. I wonder if I can actually show that right now. I can just launch the Unity game right now. So doing a Cobra maneuver like that is kind of possible. I don't think I really have... Like, the main limitation is that once you're pointing far away from the direction of travel, like once your AOA goes beyond 90 degrees, at least under my code, that makes your like control authority drop to 0. So you're no longer able to turn back towards level flight. But at least in this version, I think you can do that by modifying some of these values. Hold on, I want to disable the enemy AI so I don't have the dogfight. Okay, so if we go here to the steering curve, we modify this. That should allow us to actually maintain a large value even at low speeds. By the way, a Pukachev's Cobra is pretty much only possible at low speed. What if we, yeah, I also need to increase the strength of the turn. Basically, just doing that is how a Cobra maneuver works. And of course, it kills your velocity as well. And also by doing that, it means your plane can like basically start turning in a very tight circle at low speeds. So that's kind of how a Cobra maneuver would work. I think you actually need more than just this speed to actually like snap the nose upwards. See, I keep on going from like 900 feet to like 1400 feet, which is supposedly the correct way to do a Cobra maneuver is staying at relatively level direction of travel. So anyways, that should actually be possible with enough tuning. Okay, so I think I'm made a good amount of progress on this stream, and I'm going to close it for today. So yeah, if you want to tune in, I'll probably do another stream next week, same time, and I'll post about it on Twitter and on YouTube as well. So thank you for coming today. Very helpful comments in the chat. It's nice to see the people that are still interested in learning Godot. And I need to figure out a way to change this terrain so it's not just a gray plane. But anyways, that's a task for another day. So thank you for showing up today, guys. And that's it.